Good evening, everybody. Well, welcome to Wednesday Night Rabbit Hole. I'm Joe Slick, your host, and with me is Canuck, better known as New Brunswick Canada Guy. For those who've seen him out there on the YouTube world and some of the other nondescript channels or channels out there, tonight we are going to discuss the southern portion of the San Andreas Fault. And no, we're not saying anything's happening right now. No, we're not forecasting. No, we're not prognosticating. But what we do primarily is we look at the data and then we kind of support our hypothesis that earthquakes don't happen in a vacuum. They don't just happen randomly. There is a system behind them, and that if you observe the system, you can see reoccurrences, not necessarily in a small geographic area, but kind of a roundabout geographical area. And if you study the faults, then you can see which faults they're on. And you can see that Coulomb stress, as well as the plausibility of geomagnetic currents, better known as ley lines in for some people, or lineaments for others, or, well, I think geologists even have a couple of different terms. What are the other terms that they use there, Canuck?
Oh, all sorts of different ones. Shear zones, suture zones, all sorts of different things.
Right.
Mega shear zones.
Yeah, mega shears. And talking about the San Andreas, then would that be considered a mega shear? Because it is a plate boundary, so to speak, right?
And well, I don't know how they define it. It's just the longer it is, they use a longer.
They add a couple of more consonants and a vowel or two.
Yeah.
The woke. Yeah.
Like the Mojave Sonora mega shear zone. That's one of the first ones I read about. They were calling it a mega shear zone.
But really, Mojave what?
Sonora mega shear
zone. Wow, I need to know more about that one. That's interesting. Yeah, there's a lot of people out there talking about the San Andreas and the meaning of it. I think I know, being from Arizona and California myself, that it is very ingrained in you, that taught or fear or say, oh yeah, there's a big quake, we're due for the big one, and we're like, okay, when is it coming? Well, we don't know, but it's good, it's going to happen. Okay, what do I do? Just prepare for it. Okay, but anyway, that's kind of what I've been taught growing up from this area. And we've been studying faults in and around Southern California, the many fault systems. I think we were calling them fault zones, and each of these are related to the Great San Andreas. So my question is, have you read or come across anything, Canuck, that would suggest if one of these other main faults happened, such as, let's say, the San Jacinto fault there in the fault zone? We learned that it's 5 or 6 different segments, and each segment having a different name, and but being included to have that 80 kilometer or 120 kilometer length, combining all these because they kind of go in a long line. right adjacent to the San Andreas. And then eventually it crosses the San Andreas up at its northernmost part, um, and up there in Wrightwood, just about. And uh, have you come across anything that would suggest that, let's say we got a high 6 on the San Jacinto, um, would it suggest that if it was over on the San Andreas, that same high 6 or that same break, that the San Andreas would break harder, more violent, or, I'm trying to compare and contrast the two different faults. One fault is on the edge, and the other fault is the edge. So, is the San Andreas a different animal than all these other fault zones that we were speaking about? I think that's the real question I'm asking you. What are your thoughts on that matter?
Well, in the newest stuff, if you go to like the USGS stuff,
Mm-hmm.
they talk about all these as all being offshoots of the San Andreas. So they're all the San Andreas system.
Yeah, San Andreas system, like fingers, like these fault zones. I mean, multiple fault zones. I think we've got going east to west. We have San Jacinto, Elsinore, Newport, Inglewood. Then it goes out to sea. I think it's um, maybe the Catalinas, or maybe even um, San Diego Trough. We got the inboard and the outboard zones. And so there's quite a few going on the Pacific Plate side. We've yet to talk about on the North American side, which is east of San Andreas. I think we did up towards Garlock. And we talked about the three main fault zones up there north of Garlock. We talked about the Death Valley. We talked about the Panamint Valley. We talked about the Owens Valley. We also talked about the White Wolf Kern River Fault. And I think we talked briefly about the Garlock, which is an east to west at the southern end of all those faults. The White Wolf turning into the turning the direction of at its southern point, turn the same direction as the east-west, but it begins with a kind of a northeast kind of trend. And if you follow that up through the Kern River, that goes up almost north-south. So it kind of has that westward kind of bend to it. Whereas the Garlock is east or west to east. It goes from Tehachapi up in the mountains there, or up at the top, and then kind of goes east. And then as it gets past Searless Valley, past Panamint Valley, it starts to veer south, which is kind of an interesting, bend there. So we have a bend there and a bend upwards on the extremity of the western extremity of the White Wolf Fault. But all of these faults we've talked about all the way through Los Angeles, from San Bernardino through Los Angeles counties, all the way out to the little islands out there, the Santa Catalina Islands and the Catalina Islands. There's like 5 or 6 islands out there. We talked about all those down underneath the water, of course. And but I don't think we've actually talked anything too far in the southern section in the Sonoran Desert, which is below the Mojave. Mojave is the echelon that comes. The northern extremity is the Garlock, and the southern extremity is comes into what we saw with the Homestead Fault, and where 1992 happened and 1999 happened out there was Landers and Hector Mine. We talked about 4 or 5 faults, 6 faults up in that section, but nothing further south. In your mind, is there anything that you've come across that would suggest there's anything down there? I mean, if I open up Geo,
when we do 1887, which will be probably when we do Arizona,
Mm-hmm.
the Sonoran quake was felt in Arizona and New
Right.
Mexico and Texas. We'll go into it more detail because you can
Okay.
see once you look at those faults how they go up and connect. And
Right.
that's basically the Mojave Sonora mega shear zone.
Right. Yeah.
Because
The north of the Mojave, we talked about and I got it on film or on screen here. Let me share that with those people who are out there to um uh, what do you call it? In on YouTube and Rumble. What we've talked about is the up in the north. Here's the Garlock. We talked about Death Valley, Panamint Valley, Owens Valley. Here's the Kern River, and it turns into the White Wolf, which turns right into the San Andreas there. See how it kind of bends to the left? The Garlock kind of goes east to west. It kind of comes out and it starts to bend south. And you can almost see where Death Valley would cut the end off it and still continue. Baker Fault, down there. So it's
yeah,
almost like, go ahead.
there's other faults out there that we don't have on
Right. And
map.
and in,
They're right near the border that carry right on down.
yeah, we haven't talked about those. So what we talked about, some here, we talked about the Calico Fault, the whatever fault that one is, the Linwood Fault, and the Helendale Fault. We talked about all these different faults, which are on the eastern side of the San Andreas system here. We talked about all these faults here in Santa Barbara Mountains, Santa Clara Mountains, San Gabriel Mountains. We talked about Malibu Mountains, or the foothills. Excuse me. We talked about the San Bernardino Mountains. We talked about the San Jacinto Mountains. This is the San Jacinto Fault right here, the Elsinore Fault, the Newport Inglewood Fault, and what was this one? Coronado Bank Fault. All that was part of
Palos Verdes.
Palo Verde Fault. Yeah. Palo Verde Faults also. There's 1, 2, and then this one down here was the San Diego Trough, which is off of this one up here, the Santa Cruz, Santa Catalina Fault, which
And
splits
San
into two.
Pedro Basin Fault and
Yeah.
San
Where's the
Diego
inner? Yeah.
together. Yeah.
And these were the inners and these were the outers. So these two different fault zones, and then one more, and then one more, and then the San Andreas. And on the other side, we haven't talked about anything out here. I don't know if it's because it's just not well studied or it's unimportant to a lot of people. We talked about the Sirocco Fault a little bit. That's where Highway 10 goes all the way to Blythe. And there's some other interesting stuff in this region, even up by me up here. I'm up in the Mojave Valley up here, and which all of this is Mojave, and it's all part of the Sonoran Desert, which reaches way down into Mexico. And there's a lot of interesting characteristics that we got a northwest to southeast zones. You can see just on the little lines here, these little faults. I don't know that we've found anything that would suggest what the shearing would be or the twisting and turning, because there's an area from basically the White Wolf Fault to somewhere out here, or maybe even this one here, what we call it, the Pinot Mountain Fault. That section is turning differently, and then all this is turning differently, and the twisting turn because of compression. This is an area of compression versus this is an area of strike slip, and this is an area of strike slip up here. So these are transform faults, and it's like the pizza box is building up on one on top of another because there's something stopping it. And that's mountain building, San Gabriel's, and up here in San Inez, Sierra Mountain.
Japan region, class, moderate, magnitude, 5.1, depth, 10 kilometers, 14 minutes ago.
Oh, so Volcano Islands.
Volcano Islands again, yeah, off of Japan there. So understanding how all this works, how Southern California works, is what we were after. And I think we've covered a lot of that. Now we're going to talk about the San Andreas, the southern section, which leads from Mexico all the way up to just past Garlock. That would be the southern section. The central section would be from Garlock up to probably Salinas, and then the northern section, Salinas up further. And we're going to talk about the central section after we talk about the southern Andreas. So my question was, out here, there's not a whole lot out here that is famous. There's faults out there, but they just don't seem to be famous. And the ages of these faults, when these faults started, when these faults stopped, if they're still active, I find that a little bewildering to me, that we got all these faults out here and all these faults up here, and this is all moving north, and this is moving south. It's all twisting and turning, kind of what is it? It's going counterclockwise, and up here it's going clockwise, and down here is going counterclockwise, and over here it's going counterclockwise. So the land masses are, that is, due to all the compression that's happening. The southern portion of the San Andreas Fault, which probably, somewhere in the Coachella Valley, it turns into the Sand Hills, and then the Algonquin Fault. But it has a splay off of the Brawley seismic zone, which is the Imperial Fault zone, comes out of Mexico, what turns into the Brawley Fault and then turns into the San Andreas. And there's been a lot of earthquakes down there. And you can see all the numbers here: 1868, 1899, 1968, sorry, 1979, 1999, 1979. As we look at 1968, lots of activity along the southern portion of the San Andreas. One branch would turn it into, it looks like, into the southern branch of the San Andreas Fault, San Gorgonio Pass, which here's the San Jacinto Fault, and you can see where the San Andreas kind of splits off here, and then splits off around here through Mission Creek, and comes back to itself at the Waterman Canyon Fault. And then here's the Cajon Valley, where the 1812, we'll talk about that. 1857, we may talk about that as well. And then there's another section which leads all the way to the Garlock into Tejon Pass right there, where the Garlock hits Tejon. And that's Tehachapi, Tejon. It's all, here's Tehachapi right here. So, and Tejon's right through here. So I think we've got a kind of a picture of where we're going to be, but kind of remiss that there's nothing out here towards Blythe, and we don't know anything because we don't see anything out there.
Yeah, I asked the question. Chat.
Okay, I can't see. Yeah, go ahead.
Yeah, he asked
what makes the San Andreas Fault different from all the other faults in the area? Well, I think I said that at the beginning. The San Andreas Fault is the plate boundary, which continues down the Imperial Fault and off into the Sea of Cortez. Scientists believe that this fault goes all the way through the crust. 25 miles of crust. It goes all the way through. Whereas all these other faults are toward the surface. So within, from shallowest being up on the surface itself, down, almost down all the way. But that's the difference. I don't think the San Jacinto, the Elsinores, the Newport Inglewood, Palo Verdes, and all those. I believe all those are more shallow, and they do not go all the way through into the Moho, whereas the San Andreas does. And that's the actual plate boundary of the Pacific plate smashing up against the North American plate, which is everything east of it. And so it doesn't actually belong to the North America, but it is on the North American as we design it in a map. It's part of the ocean. And all this stuff that we see in Southern California is not part of North America, but it's part of the Pacific. And the mountains are due to the two plates crushing up against each other. And so the edge of...
It's basically the Pacific grinding up against
Yeah.
North America. So that's what it is.
The Pacific plate's moving at a much higher clip than the North American. At this location in the Southern California, Arizona, New Mexico, to Texas, the southern portion of the San Andreas, I think, is moving at about 25 millimeters a year, moving basically due west to southwest. The central part of North America is moving about 19, and the same is up here as well in North America, except for it's kind of in a more of a downward slope. This is kind of a more upward. Much of Southern Cal north of the Garlock is moving due south, and portions of it down here appear to be moving south. But I think it's just due to the smacking of the San Andreas in this Garlock region, where it's compression and not just strike slip, where it's one sliding by the other. It is sliding, but this is the connection point that has maybe 80 kilometers, maybe 100 kilometers worth of transform fault? Is that what it is? I'm not sure what. I think that's what it is. It's compressional fault. It means that both sides of the plate, both sides of the crack is pressing up against each other, and one's still sliding by the other. So,
well, I think all the faults, the cracks go through to the mantle myself, because that's the only way you get volcanoes to come up. Right?
Well, there's no volcanoes at the moment, even in the one on Salton Sea. That's kind of a plate, a plate switch. We have the Imperial Fault, which goes all the way through Mexicali into the Sea of Cortez, which ends up being the East Pacific Rise. After another 1,000 miles or plus 2,000 miles down, all the way down to Triple Junction down here. I'm wondering if this area isn't a triple junction right here, where the San Andreas kind of clips off over here, but or because there's a volcano right there that is active right here, the Brawley seismic zone, which is kind of maybe it's a kickover, because the San Jacinto Fault is really more akin to the Imperial Fault zone. But the San Andreas is broke over here. It breaks in multiple locations, but and the busiest one we see earthquakes on is the San Jacinto Fault. It's far more active than any of the others that I've just observed. But I guess from what I've read, the only one that goes all the way through is the San Andreas. But again, nobody knows, right? They don't have magic eyes that looks through the dirt, whatever the depth is here. I'm assuming that it's 25 to 50 kilometers in depth, and because it is pretty close to the ocean. But if it's part of the ocean, then it goes all the way to the Moho. And I don't know the depths of the crust, and because this area, the San Andreas in the south, it's sea level, same as out here, out in here. So there's a big bulge in the middle due to the two plates smacking up against each other. And we have faults breaking through as this pizza box lifts over this pizza box, which lifts over this pizza box, which pushes up against these and makes these mountains. So I guess that's what I'm seeing or hearing. But I hope that answered much as it can be done.
Yeah. Well, I think it's rotating because of the big bend that's there. So all the stuff is making it.
Right. The
rotate.
big bend of compression here. Because it's not flat like this central part of the San Andreas where it's easily, you can see this one sliding by this one, right? It's because this is sliding at that northwest direction and it's banging up against North America. It's already done something, and Baja is moving north with it. You know, it looks almost like Baja used to be part of here, and it broke, and it's floating up north.
Because
Right along
in
with
the
this.
new stuff, it says the San Andreas is a system of dozens of faults, including the east-west ones.
Mm-hmm.
That's what the new stuff says.
That's the system, right?
Yeah. Because all it's doing, the east-west ones are taking the stress and distributing them across to the other ones. That's basically what they argue in the latest stuff. So it's wild.
Yeah. I mean, depends on which article you read, and in the future we'll be posting these articles on our website so that you can refer to the things that we were referring to, and hopefully I'll get that up, by the end of the year.
But tonight we're just going to
tonight.
start with San Andreas wiki first. Right. It's pretty detailed for what we need to do.
All right. So you have a starting point you want to do, bud?
Yeah. I'm just going to start reading the whole thing. It's going to talk about all the segments again, but we'll deal with the North stuff later. But
did you already post it in?
Yeah, I sent you all the
links,
so they should be there.
All right, but I'll go so I can
like
follow along.
6 or 7 of them tonight.
All right, cool. All right, so yeah.
So
starting with the San Andreas fault. Okay, cool.
Yeah.
All right. I'm just opening the pages.
I'll wait till you get it up there.
The GIA. I already got the GIA up. Oh, I was doing the GIA. Drying salt and see.
Yeah, we're gonna do GIA again 3 times tonight. So you'll be an expert on it by the end of tonight.
Yeah. I already have it open too, by the way.
Oh, well, there.
Okay, 1, 2, 3. Immedius. All right. Immedius, and then we'll go to the wiki, and then we'll go to that one, then Tajon, then I'm not going to tell you I had a headache. I still have a headache. All right, so I have them all. So I'm going to put this over here and share this tab instead. Go right ahead, bud.
Yeah, now, so we're going to talk about the main area here first, and then we'll go from there.
We use the wiki just for references. It's not, all correct, just to qualify that, but it's pretty good.
Yeah, it's like the simple version of it.
Yeah.
So read that off. The San Andreas Fault is a continental right lateral strike slip transform fault that extends roughly 1,200 kilometers, 750 miles through the U.S. state of California. It forms part of the tectonic boundary between the Pacific Plate and the North American Plate. Traditionally, for scientific purposes, the fault has been classified into 3 main segments: northern, central, and southern, each with different characteristics and a different degree of earthquake risks. The average slip rate along the entire fault ranges from 20 to 35 millimeters, 0.79 to 1.38 inches per year. In the north, the fault terminates offshore near Eureka, California, at the Mendocino Triple Junction, where three tectonic plates meet. The Cascadia subduction zone intersects the San Andreas Fault at the Mendocino Triple Junction. It has been hypothesized that a major earthquake along the Cascadia subduction zone could trigger a rupture along the San Andreas Fault. In the south, the fault terminates near Bombay Beach, California, in the Salton Sea. Here, the plate motion is being reorganized from right lateral to divergent. In this region, known as the Salton Trough, the plate boundary has been rifting and pulling apart, creating a new mid-ocean ridge that is an extension of the Gulf of California. Sediment deposited by the Colorado River is preventing the trough from being filled in with seawater from the Gulf. This fault was first identified in 1895 by Professor Andrew Lawson of UC Berkeley. In the wake of the 1906 San Francisco earthquake, Lawson was tasked with deciphering the origin of the earthquake. He began by surveying and mapping offsets such as fences or roads that had been sliced in half along surface ruptures. When the location of these offsets were plotted on a map, he noted that they made a near perfect line on top of the fault he previously discovered. He concluded that the fault must have been the origin of the earthquake. This line ran through San Andreas Lake, a sag pond. The lake was created from an extensional stepover in the fault, which created a natural depression where water could settle. A common misconception is that Lawson.
Hey, bud, they can't hear you. I'm hearing that. All right. All right. Oh, we'll try to work that out, Clem. Thank you, bud.
You bet.
I guess they can't hear you, Clem.
They can't hear me.
Yeah, they're not able to hear you.
Oh, that's crazy.
No, wait. They say you can hear you now. All right. So do a summary of what you said. Just kind of San Andreas broke into three sectors: the northern sector, the central sector, and the southern sector. The southern sector is comprised of what is it? What kind of fault? I mean, it's not transform, but it's the other one where it's spreading apart. And I think that's basically where you're at.
Okay. So the history part then they didn't hear.
All right.
Yeah.
Yeah. For some reason, we weren't able to hear you.
Okay. The fault was first identified in 1895 by Professor Andrew Lawson of UC Berkeley in the wake of the 1906 San Francisco earthquake. Lawson was tasked with deciphering the origin of the earthquake. He began by surveying the mapping offsets, such as fences or roads that had been sliced in half along the surface ruptures. When the location of these offsets were plotted on a map, he noted that they made a near perfect line on top of the fault he previously discovered. He concluded that the fault must have been the origin of the earthquake. This line ran through San Andreas Lake, a sag pond. The lake was created from an extensional stepover in the fault, which created a natural depression where water could settle. A common misconception is that Lawson named the fault after this lake. However, according to some of his reports from 1895 and 1908, he actually named it after the surrounding San Andreas Valley. Following the 1906 San Francisco earthquake, Lawson also concluded that the fault extended all the way into Southern California. In 1953, geologist Thomas Dibley concluded that hundreds of miles of lateral movement could occur along the fault. An NSF-funded project called the San Andreas Fault Observatory at depth near Parkfield, California, involved drilling through the fault from 2004 to 2007. The aim was to collect core samples and make direct geophysical and geochemical observations to better understand fault behavior at depth. And so now it's the next section is going to talk about how they break each segment down farther. The northern section is what we're going to talk about here next. The northern segment of the fault runs from Hollister through the Santa Cruz Mountains, epicenter of the 1989 Loma Prieta earthquake, then up the San Francisco Peninsula, where it was first identified by Professor Lawson in 1895, then offshore at Daly City near Muscle Rock. This is the approximate location of the epicenter of the 1906 San Francisco earthquake. The fault run returns onshore at Bolinas Lagoon, just north of Stinson Beach in Marin County. It returns underwater through the linear trough of Tamales Bay, which separates the Point Reyes Peninsula from the mainland, runs just east of Bodega Head through Bodega Bay and back underwater, returning on shore at Fort Ross. In this region around the San Francisco Bay Area, several significant sister faults run more or less parallel, and each of these can create significantly destructive earthquakes. From Fort Ross, the northern segment continues overland, forming in part a linear valley through which the Guala River flows. It goes back offshore at Point Arena. After that, it runs underwater along the coast until it nears Cape Mendocino, where it begins to bend to the west, terminating at the Mendocino Triple Junction. So that's the north segment, but we'll talk about that in more detail when we do all the San Francisco quakes. The central segment of the San Andreas Fault runs in a northwestern direction from Parkfield to Hollister, while the southern section of the fault and the parts through Parkfield experience earthquakes. The rest of the central section of the fault exhibits a phenomenon called a seismic creep, where the fault slips continuously without causing earthquakes. It was formed by a transform boundary. Now, the southern section, which is what we're going to focus on tonight when we look up all the big historical quakes on it. The southern segment, also known as the Mojave segment, begins near Bombay Beach, California. Box Canyon near the Salton Sea contains upturned strata associated with that section of the fault. The fault then runs along the southern base of the San Bernardino Mountains, crosses through Cajon Pass, and continues northwest along the northern base of the San Gabriel Mountains. These mountains are a result of movement along the San Andreas Fault and are commonly called the transverse ranges. In Palmdale, a portion of the fault is easily examined at a road cut for the Antelope Valley Freeway. The fault continues northwest alongside the Elizabeth Lake Road to the town of Elizabeth Lake. As it passes the towns of Gorman, Cajon Pass, and Fraser Park, the fault begins to bend northward, forming the Big Bend. This restraining bend is thought to be where the fault locks up in Southern California, with an earthquake recurrence interval of roughly 140 to 160 years. Northwest of Fraser Park, the fault runs through the Carrizo Plain, a long treeless plain where much of the fault is plainly visible. The Eichhorn Scarp defines the fault trace along much of its length within the plain. The southern segment, which stretches from Parkfield in Monterey County all the way to the Salton Sea, is capable of an 8.1 magnitude earthquake. At its closest, this fault passes about 35 miles, 56 kilometers to the northeast of Los Angeles. Such a large earthquake on this southern segment would kill thousands of people in Los Angeles, San Bernardino, Riverside, and surrounding areas, and cause hundreds of billions of dollars in damage. Now, the next section here talks about the plate boundaries themselves. The Pacific Plate to the west of the fault is moving in a northwest direction, while the North American Plate to the east is moving toward the southwest, but relatively southeast under the influence of plate tectonics. The rate of slippage average about 33 to 37 millimeters, 1.3 to 1.5 inches a year across California. The westward motion of the North American plate towards the Pacific is creating compressional forces along the eastern side of the fault. The effect is expressed as the coast ranges. The northwest movement of the Pacific plate is also creating significant compressional forces, which are especially pronounced where the North American plate has forced the San Andreas to jog westward. This has led to the formation of the transverse ranges in Southern California, and to a lesser but still significant extent, the Santa Cruz Mountains, the location of the Loma Prieta earthquake in 1989. Studies of the relative motion of the Pacific and North American plates have shown that only about 75% of the motion can be accounted for in the movements of the San Andreas and its various branch faults. The rest of the motion has been found in an area east of the Sierra Nevada mountains called the Walker Lane or Eastern California Shear Zone. The reason for this is not clear. Several hypotheses have been offered and research is ongoing. One hypothesis, which gained interest following the Landers earthquake in 1992, suggests the plate boundary may be shifting eastward away from the San Andreas towards Walker Lane. Assuming the plate boundary does not change as hypothesized, projected motion indicates that the landmass west of the San Andreas Fault, including Los Angeles, will eventually slide past San Francisco, then continue northwestward toward the Aleutian Trench over a period of perhaps 20 million years. So they're given all sorts of interesting facts in that section. The San Andreas began to form in the mid-Cenozoic around 30 million years ago. At this time, a spreading center between the Pacific Plate and Farallon Plate, which is now mostly subducted, with remnants including the Juan de Fuca Plate, Rivera Plate, Coxos Plate, and the Nazca Plate, was beginning to reach the subduction zone off the western coast of North America. As the relative motion between the Pacific and North American plates was different from the relative motion between the Farallon and North American plates, the spreading ridge began to be subducted, creating a new relative motion and a new style of deformation along the plate boundaries. These geological features are what are chiefly seen along San Andreas Fault. It also includes a possible driver for the deformation of the Basin and Range, separation of the Baja California Peninsula, and rotation of the transverse ranges. The main southern section of the San Andreas Fault proper has only existed for about 5 million years. The first known incarnation of the southern part of the fault was
how many years?
5 million, the very southern section. So down by Salton Sea.
Okay.
Yeah. So the first known incarnation of the southern part of the fault was Clemens Well Fenner San Francisco fault zone around 22 to 13 million years ago. This system added the San Gabriel Fault as a primary focus of movement between 10 and 5 million years ago. Currently, it is believed that the modern San Andreas will eventually transfer its motion toward a fault within the Eastern California Shear Zone. This complicated evolution, especially along the southern segment, is mostly caused by either the Big Bend and or a difference in the motion vector between the plates and the trend of the fault and its surrounding branches.
All right, so studies relative motion plate on about 75% of motion can be counted to the movement of San Andreas as various faults, blah, blah, blah. Read is not clear. Several hypotheses have been offered branching. Hypothesis gained. Okay, that's down further. You're talking about the formation. Is that where you're at or the early years?
Yeah, I'm just ready to start the early years part.
Okay, hold on a second. You picked up something pretty interesting that brought to my attention. I was determining what 1.5 inches a year does in 10,000 years, and it's basically a quarter of a mile, or what is it, or 0.2367 is the like about a quarter of a mile, I guess. So it's 1250. That's what it does in 1250 feet in 10,000 years. That section of the San Andreas moves. And I'm saying, well, okay, every 10,000 years it moves 1,250 feet. How many miles is 1,250 feet? And I think it's about a third of a mile, right? So I was thinking that, and then you brought something up when you were reading that on alien plate boundary.
Yeah, but see, we've in the other ones we've done previously when we read the studies on each individual fault, the rate which it was slipping was different depending on different times.
Right,
so
right.
I'm assuming it's the same with this because they're saying the southern part is only 5 million years old.
Yeah, which doesn't make sense to me. What was it before 5 million years?
Well, they called it that other one. I never heard tell of the name of that big long name they had there. So there must have been another fault that was there before that was northwest to southeast. And that's
Lake Kahula?
No, it gave a big long name there that was like.
Hold on, that's what.
Yeah, I never heard tell of that. Clemens, Well, Fenner, San Francisco fault zone. And they're saying that was there around 22 to 13 million years ago. So I don't know where that is in relation to what we're talking about now. But it must have been some other fault zone that they know previous to this. Because I've never heard tell of Clemens, Well, Fenner, San Fran.
Yeah. What page, what part of the page is that in? Because I can't find it even to say the words.
Yeah, it's right above where the early year section is. There.
Okay. Right above that. All right.
Yeah, I understand the San Gabriel fault part because when we studied that one, they said it was a precursor to the San Andreas.
Yeah, the main section of the San Andreas Fault proper only exists for about 5 million years. The first known incarnation of the southern part of the fault was the Clemens Well Fenner San Francisco means a little Francis. Okay. Fault zone 22 to 13 million years ago. Clemens Well Fenner. Where the hell's that?
I don't know. I don't think that's on any of the current maps.
Okay, San Francisco Keter is okay. I know where that is now. That's north of Los Angeles, and not quite Garlock. So there's a lake. It's right here. Interesting. This area right here, Fraser Park. That seems to be the birth of it.
Yeah, because see how they're explaining, like when it started bending, right? So then it readjusted it to the south, and it did that last.
All right. So basically, the North America came up here. The North America is, I think how they're saying it here. If I just add another. Another screen here for it and then share my famous my famous drawings. I draw a lot. Here go like that and go like this. All right, so North America. Oh, hey, what are you doing there? North America basically has a shape like this. The Pacific Ocean is out here. As the plate of the Pacific, the edge of the plate, and this whatever subducted beneath North America, I think that's how Baja broke off. But again, that's my argument. If I did again, as we know, California, right? And then we got Baja out here, basically Mexico out here, right? And Baja kind of comes down like this. Um, don't worry about this one out here. But there's a fault that comes up through Baja and it turns into the San Andreas and it kind of does that thing. Um, this edge of the boundary was out here, I guess somewhere between 22 and 25 million years ago. I don't know when Baja was created, but what we're talking about is this portion in Los Angeles, right up in here, started 5 million years ago. So that would suggest that this whole southern section was doing something in doing something. And if I showed you a picture of the USGS and took a picture of it here, it's much easier if I did this. Go like this, right here, because this is kind of interesting. Close that. We're already sharing. Okay, we're sharing this. Save file. Open this one here. There you go. And I'll zoom in for you. This portion down here, this is the southern section they're saying was done 5 million years ago. Okay. Let me draw this here a little better. 5 MA. But they're not saying anything about this down here. But all of this section moved like that. And this is moving like this. So as it hit the plate, the edge of the San Andreas or the edge of the plate up here, the whole Pacific Ocean, right? It's a plate. This came across and this broke 5 million years ago. That's the theory. Prior to that, this sector here was out here. And as it went anteriorly, it went underneath Baja, broken off from this point to this point, and drew it that way 400 miles, which is the same distance from this point to this point, 400 miles. So if you can find the time it took for the southern Andreas 5 million years ago to do what it's doing, you can probably find the gap that happened down here, the 400 miles.
Because they say Walker Lane's not that old either.
Right.
So fairly new.
I think it's all related to the crashing and the change of subduction. See, this portion here was already strike slipping. And we know what a strike slip is, going like this and going like this, right? But this portion down here, this is 5 million years ago. This one right up in here, you said was 25, right? Am I right?
Yeah.
25. So something's happened in the last 5 million years for this strike slip to move down this direction to this here. Did it take 5 million years to traverse Baja? I think so myself. I think the southern edge was out here, and the movement of North America going across, moved it from there to there. Because it like there's a whole subduction down here. You know, and most of us who study these things know this is all subduction. This is the spreading center. And we've learned that down here it's spreading as well. And the southern and portion of here where it's compressional, it's not spreading. And then we know up here it's strike slipping. There's 3 different sectors of this whole thing, and the sector right to here is, basically 750 miles, and then from here down to here it's quite long, probably around the same. But the part where Baja moved off of this coast is 400 miles. It's the same number from the Delta to Lompoc, 400 miles. So I think that's related. That's what I'm hypothesizing. That's what I'm saying. It's saying, but there's really nobody is even talking about it, because you can look on Baja right here, and Cabo San Lucas came out of the Puerto Vallarta. Here's some more drainage, because the San Andreas not San Andreas, but the plate boundary comes here and it turns out this way. And where did this come from? Right? And if we're believing that the San Andreas is moving this way at a quarter of a mile every 10,000 years, 5 million years is, I don't know, how far does it go in 5 million years? That's 10 times a quarter of a mile, right? For every million. So what is that? 5 miles, right? No, wait, how many quarter miles go into a? I'm getting myself confused. I'm not great in math, so don't get me wrong, but the idea is there.
Do all those calculations. That's when it gets.
Yeah, I mean,
why I ignore them altogether.
Yeah, you ignore them, but I'm intrigued by them, because that's where a lot of the arguments start. They say, well, okay, 5 million years ago, this portion of the San Andreas began. Okay, well, what happened before that? What was it doing before that? They never tell you.
Well, there was another fault there that was doing something.
They didn't say that. They didn't say that. They did not say that. They did not say that.
Well, they said there was one that was there 22 to million years ago.
This one up north was 22, right? The one from El Tajon Pass north, it was there 22 million years ago.
But the southern section wasn't.
The southern section wasn't. Why?
It's just a come along lately one.
Yeah, Johnny come lately, yeah.
But I don't want to get bogged down on that.
I know it. I find it interesting, the date that they give you, 5 million years ago.
Yeah, we don't want to be talking about it for 5 million years.
No, especially, I mean, how many ice ages is that, man? Shoot, that's like 4 ice ages, right?
And it's thawed out and rethawed multiple times.
Yeah, so yes, sir.
Cracks filled in with ice and unthawed.
And then all this stuff happened when it was down here in Chihuahua, because North America's moved north,
Yeah.
But anyway,
it was good palm trees.
So that's the thing. And some of these, we're understanding the faults and where they're at, and I can appreciate that. But when they start giving dates, I go, whoa. What do you mean? And then back it out. How do you roll it backwards? There's a volcano that is right here at the area that they talked about, right here, because here's the home pass, right here, the Macamba. I think it's Macamba. it got split in half, and the other half's up here. And Pinnacles.
Yeah, Neenak.
Yeah, Neenak. Okay.
Half is
That-
the Pinnacles, and the other half is the Neenak Formation. That's
right.
still
That's
there.
like 400 miles.
Yeah.
So if that's 400 miles and the other thing's 400 miles and 5 million years, is all that related? Maybe that's what split the darn southern half was MEMAC, or I don't know. They'll probably give us a date on MEMAC, right?
Yeah, so Neenak was like a volcano on Garlock, basically,
Yeah.
before the San Andreas split through it. That's what it says when you read up.
Yeah, that's Neeanach volcano.
Yeah. And they called it that because half of it, the formation, the Neenak Formation, right there by Garlock. And then when they dated all the rocks, they found the Pinnacles was the same.
Right. And it's 23 million years ago. And that's exactly what we just said. That 23 to 30, right?
Yeah, well, see, that's that other fall up by there that was 22 to 13 or whatever they said.
Yeah. There is a graph here that talks about off the coast of Southern Cal, the Cocos Plate. Wow. Farallon Plate was off 30 million years ago. It was the Pacific Plate. Farallon Plate was in Los Angeles 30 million years ago.
Yeah. Well, and they say that the JDS
and Los Angeles is where the edge.
Rivera and Cocos and Nazca are all like
right
leftover pieces of Farallon, but
right breaking off as Pacific Plate at a point. Here, I'll just share this tab. At a point, it came in 30 million years ago, smacked at Los Angeles. Here's a subduction zone. Smacked Los Angeles, spread apart. Cocos Plate's moving south. The Juan de Fuca's moving north. And 5 million years ago, when the San Andreas started, the Gulf of California closed up. Tres Minas Islands is out here. All this is Baja. And then as the plate kept going north or going inland, they're saying the same thing I am. It went underneath Baja. See right here, the transverse range right here. Here's Baja. It went underneath Baja. See that? This is the 5 million years ago, and then this is current day. So I think you can see that. Yeah, you can. So this is 5 million years ago. Here's Baja. It went right through underneath Baja. The transverse or the strike slip right here. It was out to sea. Here's Los Angeles. Here's the trench, Cocos Plate, which is south of Baja. Yeah, so they're saying the same thing I am. I just didn't know how to explain it. Yeah. How did it? I know it was on one side of it and it broke Baja off, So there you have it, baby. Yeah. And then we have the creation. The strike slip was always offshore, and then it went interior here. 5 million years ago, it started to go interiorly.
And before that, it was going to BC, but we don't want to get into that right now.
All right. So, and this, I know I'm pretty crazy on you. I apologize for, taking up your time, but if you have, the Pacific Plate coming in to North America, this is on its side, right? That's north. All right. It's coming in because it's going north. It's moving north. This is moving this direction. This points and hits this. Here's Los Angeles. It hits here. This is a subduction of the Cocos plate. As this strike slip right here gets in, it starts, then it comes to here, then it comes to here, then it comes to here, right? Because this is moving and this is moving in that direction too. The Pacific plate, right? It's here then, it's here now, and then it's up here, right? And then the edge of it would be right here. All this subduction keeps going down there. And the edge of the, let me draw it like this. They might be able to see it a little better. This was the strike slip. This was it. This was it. This was it. And now it's all this moving up, okay? So over millions of years, this is the current one. This is 5 million years. This is 10. This is 15. This is 20. And the edge of North America was right here. Right. So as North America moved across in conjunction with this Pacific plate moving inward, that's why there's so much compression here. And that's why this fault is started 5 million years ago in Southern Cal. It existed already, but as North America went across the edge and was driven into it, it broke pieces off the edge, pieces off the edge, pieces off the edge. The main portion of the strike slip is always on this edge. That's what is being translated onto North America as North America and the Pacific collide. That's how I'm seeing it. Is that how you see it?
Yeah.
All right. Back to it.
Okay, so now we're going to go back to the current research section because that's what we're going to talk about a few of those quakes.
Okay.
So current research, seismologists discovered that the San Andreas Fault near Parkfield in Central California consistently produces a magnitude 6 earthquake approximately once every 22 years. Following recorded seismic events in 1857, 1881, 1901, 1922, 1934, and 1966, scientists predicted that another earthquake should occur in Parkfield in 1993, but it didn't. It eventually occurred in 2004. So 2004 was the last time Parkfield had a 6. Due to the frequency of predictable activity, Parkfield has become one of the most important areas in the world for large earthquake research. In 2004, work began just north of Parkfield on the San Andreas Fault Observatory at depth. The goal of SAFOD is to drill a hole nearly 3 kilometers, 1.9 miles into Earth's crust and into the San Andreas Fault. An array of sensors will be installed to record earthquakes that happen near this area. So they've been studying that for a while, and this is when they found out this was the first one they drilled into down, whatever it was, 3 kilometers, and they found all the serpentinite rock in it the farther they went down. So that's what all the new studies say. So now they're drilling into all the faults. Doesn't matter where it is. Yeah, they're doing that.
I don't know. For me, it's like, it's kind of dangerous, don't you think? Because what if the place they're drilling is a place where exactly where the Coulomb stress and all that is pointed right at that spot, and they click it, and all of a sudden, boom.
Because they're up doing, the last I read, they're doing all the Northern California ones now. So they're on like Maycoma and
that's way up there. Yeah,
all those ones. So that was the last time I read, but they're basically drilling into every one they think that's like a major one. And they've been drilling in New Madrid for a while too, because they started doing that one after they started doing at Parkfield. So anyway, but that's another tangent to get onto. So
Hey,
The
man's
next-
rabbit hole, man. Come on now.
Yeah.
Ease up, buddy.
A 2023 study found a link between the water level in Lake Kauai, now the Salton Sea, because the Salton Sea's only been there since 1905, and seismic activity along the southern San Andreas Fault. This study suggests that major earthquakes along this section of the fault coincided with high water levels in the lake. The hydrological load caused by high water levels can more than double the stress on the southern San Andreas Fault, which is likely sufficient for triggering earthquakes. This may explain the abnormally long period of time since the last major earthquake in the region, since the lake has dried up. So the last time Lake Kauai was gigantic was 1730.
I think we were talking about that a few weeks ago.
Yeah.
That's this portion of the Salton Sea, just north of it. It's all the Coachella Valley. It's all sea level, and it floods out. And when it floods out, there are major earthquakes and volcanic activity. We've came across both of those events in our studies. So the southern part of the San Andreas here, the Brawley area, when it floods out, and I think Fort Yuma, when we had our first, it's funny how I know I'm all over the place. That's because I'm into this stuff right now. You got me going. My brain's going ding, 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 ding. But it's funny how Fort Yuma and that event at Fort Yuma keeps reoccurring in our discussions because I'm bringing it up, one, but also that what we've learned in Fort Yuma was they were able to see the volcanic activity somewhere out here, and they can see the rising of it. And this is, it's far. The Colorado River used to come up all the way through here and up through Yuma and up through Blythe and up to Grand Canyon. You used to be able to travel that. Don't travel it no more because we've dammed it all up and did what we did, drained the darn thing. But if we would have left things alone, there's a very good chance that we would have saw the major volcanic activity that happens down here, also that happens here in the Imperial Valley, and the flooding of the Salton Sea. I think you may have suggested it. I'm pretty sure you did, because we're all wondering, how the heck did it get flooded? Was it just the mountain, snow, and that kind? Or was there an earthquake, that when the water level was, or the land was lower than sea level, and then there's an uplift? Don't know. Maybe the crunching of, I don't think so, but there's got to be a reason and a way for the Salt Sea to gain water.
Yeah.
And
I explain it in that next article, which is what we're going to go to now.
Okay. So next, the drying of the Salton Sea. Is that the one?
Yeah.
All right. So are you done with this one, or do you want to go to that one, or what do you want to do? You want to finish where you're at?
Yeah, we're going to go to this one because it ties into what I want to do next.
Okay. All right. Share this tab instead. All right. The drying of the Salton Sea has starved off earthquakes for now. The San Diego State University geophysics Matthew Weingarten and Riley Hill explain how previously high water levels in the lake bed have triggered major earthquakes. That's so apropos of what I was just saying, wasn't I? The southern end of San Andreas that runs directly below the Salt Sea, Southern Cal, currently poses the largest seismic hazard in the state, but it hasn't experienced a major earthquake in more than 300 years. Now, a new study in the journal Nature by scientists from the San Diego State University and San Diego Scripps Institute Oceanography has found that the Salton Sea has dried up. It has eased the strain on the part of the fault, potentially postponing a quake that could devastate Los Angeles. San Diego News Center, Suzanne Clara Bard asked geophysics graduate student Riley Hill and his advisor, Matthew Weingarten, about what's going on in the future. Salton Sea, which is a remnant of the much larger ancient Lake Cahuilla, has gone through many cycles of drying out and filling up again due to the fluctuations in the climate. Your study found that over the past 1,000 years, major earthquakes took place every time the water levels in the lake reached a high point, about every 180 years or so. Why is that? And Hill said the ancient Lake Cahuilla held approximately 40 times the volume of the water as today's Salton Sea, which is an area of 6 times the size. The lake filled and dried up periodically over the last 1,000 years. When the lake could fill up a large enough bend in the upper crust of the earth, this is like taking a ruler and bending in the middle, unclamping the two sides of the fault and causing it to slip. Another effect is the fluid of the lake itself. The cause an increase in pore pressure, which also makes it easier for the fault to slip. A puck on the air hockey table is a good analogy. So it slides real easy, right? And the increase
all the new studies are talking about this pore pressure thing. You'll see.
Yeah, I keep running across it too. Yeah. The increase in pore pressure from the fluid is like a turn the air on when you got that game that we used to play, air hockey. It pushes out to the sides of the fault, making it easier for this thing to slide, thus triggering an earthquake. Salton Sea has experienced relatively dry period since the 1730s. 300 years ago, Los Angeles and Northwest has experienced plenty of destructive earthquakes originating in southern San Andreas Fault since then, but none of these has topped the magnitude 7 on the Richter scale. And this is written at 2023, by the way, everybody. Hill said the drying of the lake contributed a small part to the clamping of the fault. However, this does not fully explain why we have not had a major earthquake during this time. We have a direct geodetic measurements on the section of the San Andreas Fault. Regardless of any of the minor clamping effects, the drying up of the lake has had the accumulation of stress from the tectonic plate motion has built up considerably over the past 300 years and will need to be released. If all the stress is released at once, the fault has the current potential for a major 7 plus magnitude earthquake. And I think I have. Did I? Wait, did I? Yeah, I have a. I think I have a. Go ahead if you want to add something to it. You can go right ahead, bud. Because
yeah, I think they're so worried about the southern section.
Right. I think I have a documentary that I can point to that will simulation here in California. This is this San Francisco? Crap, I think this is the wrong one. San Diego. Okay, this is the one. All right, so this is from San Diego. 8 years ago, they put this one up, okay? So I'm going to share this with you. And this is a simulation done from a fault that happens down here at the Salton Sea.
Yes, Bombay Beach, Salton Sea.
Bombay is right here.
Yeah, right. And it's based upon this quake that they now think happened in 1690. Right.
Okay, from 1690, right? So this is basically what happens. There is no sound to it, so nothing to worry. So earthquake happens right here, and this is how it rolls up through Palm Springs. And finally, Oceanside is feeling it. They go into San Bernardino. And the different colors mean more strain, right? And you can see San Bernardino getting banged real hard. And Santa Ana, Long Beach, they start feeling really, really radically. And through the Pasadena Mountains, through Lancaster, up towards Garlock. It's about to hit Garlock right now. And it's hitting Garlock now at Tahome. And this is what happens. And you can see the relative motions that these areas will feel as that quake rips up the San Andreas at a magnitude 7.8. And you can see one line comes up through the Santa Maria, right? Or that would be Santa Ynez fault zone, quite possibly right there. If I looked at that fault, I would tell you, because it's just Oxnard.
Yeah, it's all coming out through that.
Yeah,
area.
that would be the Santa Rosa fault. Yeah, that's the Santa Rosa fault coming through here. And the Santa Ana fault would be, actually, that'd be the Santa Ana fault. The San Cayento, the Hollister fault, right? It goes all the way and comes down to the Santa Maria, goes right through here. But
So
this
it's
avenue,
reverberating along the transverse ranges, basically.
yes, right through the Halser fault, San Cayeno fault. Remember we talked about that first, and the Oak Ridge fault, right through here, all the way out through Oxnard, and just north of Oxnard is Santa Barbara, and you can see how it would affect it. But the damage is done. San Bernardino, Long Beach, on a 7.8, which would be completely freaking devastating. And a 7.8 would probably move 25 feet.
So the 1690 number comes from the trenching they did near Bombay Beach, Salton Sea, between 2006 and 2011. So from what they did there, they figured out the last time it went off big at Bombay Beach, Salton Sea area was
1690. All right, I'm
Yeah.
looking it up.
Well, you won't find too much when
1688, 1690 Peru. Peru had a quake in 1690. The Lesser Antilles did too.
Yeah, but I want you to look back 2 years before and 2 years after.
All right. And
And you'll see-
to Mexico, 1688.
Yeah.
Yeah.
And click on each one and it'll tell you what.
Yeah, that's what I'm doing. Didn't tell me where this one's happening. 1688, more info. It's not telling me. Oh, there's a paper in there.
Yeah, sometimes it says, sometimes it doesn't. So.
All right, hold on. I just got to.
That one says 6 or something.
Right here. Well, seismic history of the middle of 15 to 2000. All right. Didn't tell me historical seismicity. Said 1773. What we were looking at, 1790.
1690.
1690.
Yeah. So we're going 2 years before and 2 years after.
Yeah.
You'll see what's happening.
Yeah, exact matches. All right. By 1690, the number of taxpayers in most towns had more than doubled, and many additional towns supported at least 1,000 taxpayers, enough that we could produce fairly reliable intensity maps. So during the early decades of that period, the size of damage areas might be somewhat underestimated. By 1830, many of the towns of Guatemala and El Salvador contained more than 5,000 eligible. 1617, we were not able to find information sufficient distribution of towns to produce reliable intensity maps.
Yeah, because the farther they go
7.4 I got right here. El Salvador would have not escaped our detection. However, we believe that catalog may be complete with both greater than 7.4 thrust events and for a greater than 7.4 downgoing slab normal faulting events shallower than 60 kilometers since 1690. So thickness is going slab is small. Right curvature may. I'm trying to read and find out what size that 1690 would be. Maximum intensity of 27 events with the largest since 1690.
Well, see, Mexico went off in 1688. Guatemala went off 1689, February 12th.
Yeah, southern Mexico. That's where they got it. Yeah. 1743, southern Mexico.
Yeah, you're getting too many other numbers.
I know, right?
Because they're giving all the other ones. I just want to concentrate on what happened like 2 years before Southern San Andreas went off and 2 years after, because you'll see it's the same.
That's the Peruvian. Yeah.
You'll see it's the same pattern as it goes. Starting in 1688, Mexico goes off.
Yeah, southern Mexico, Chiapas area is down on the border by the border of Guatemala, and then again, looks like Lima, Peru, in 1690.
But see,
another 7.2.
You're leaving out Guatemala and Antigua, which Antigua is the Caribbean. Lesser Antilles is the Caribbean.
Oh, is it? Okay.
So see what's happening. It's going Mexico,
Guatemala,
Caribbean, Peru, DR, Caribbean again.
Then there's Caribbean again, Antigua, 1691. Then Jamaica.
And these are all like 6 and 7s. Some they say it could have been close to 8 if you look up each one.
Right.
So over that 4-year period, either side of when Southern San Andreas went off, because they don't know what time of year it was. They just know it was 1690.
Okay.
So it could have been at the beginning, the middle, or the end.
Sure.
So when I went back, I just wanted to see what it was doing I started a year, but then I saw the other ones and I said, well, look what it's doing the 2 years before and the 2 years after.
Right.
So it's the same pattern again. South America, Caribbean,
right.
Central America going wacko.
And North America being San Andreas there.
Yeah.
Well, makes sense.
Yeah. So they don't have the San Andreas on this one because they don't have anybody recording it that it happened on the San Andreas, because then it was just the Indians there then, the indigenous peoples in 1690, because the Spanish weren't up there yet.
Well, what happened shortly after 1690 was Peru went off, and then 1700.
Yeah.
The Cascadia.
Yeah, so 10 years after the Southern San Andreas went off, you had Cascadia.
Right.
Which is why I say, based upon what I know now, we should get a big, gigantic quake in the Southern San Andreas before.
Well, you have to go to the 1937 dream. Refer back to that. It touches everything that you and I have spoke about on our theory, our hypothesis, saying that there is a connection with South America, Central America, the Caribbean, and Southern Cal, and up through the north, from even up to in Northern Cal, the California-Oregon border, as well as the Cascadia. That I wonder if we were able to find articles that the previous 1700 earthquake, this is the mega quake up there that happened, the one prior to that, I wonder what year that was. Was it not 900 something?
Well, that was Seattle fault. It was 900.
Yeah. And
I think Cascadia went off again. I think it was like pretty close to that time, like 870 or 880.
Yeah, that's what I'm trying to get at. And there are other signposts that suggest that Southern Cal went off real big around that same time, as well as 1812, 1811's quakes, and
because we're going to do 1812 next
Right.
using the same one, and you're going to
well,
see
that's
that
kind of where I'm going at. So if we're talking about 1700 and prior to 1700, just 10 years, we're seeing that the Southern California popped real hard, and that what led to that, or what's prior to that, was the Caribbean banging up real good, Peru banging real good because it went off like 3 times, 1696, 1697, 1699, and then bam, 1700 up there in Cascadia. But in the meantime, we have Jamaica, Argentina. I don't know where San Miguel is. I think that's south down there as well.
yeah, and it's not on this list either, but New Madrid went off in 1699 too, near Memphis.
Yeah, that's what I was getting. I think there's a correlation.
Which was Christmas Day, 1699. So exactly 1 month before Cascadia,
Right.
which was January 26th.
And when dealing with earthquakes, we don't deal with a microwave where if it didn't happen within a day or two or a week, it's unrelated. No, that's bull crap. Ridgecrest happened some 35 days or so or more after the Peruvian 8. And
because I've studied all the
19.
quakes in the 1600s on the East Coast, 1663 was Montreal, which was Charlevoix seismic zone, and they say it was big as New Madrid now in the newer studies, so 7+.
Really?
Yeah. And then 1638, which would have been 30 years before that, New Hampshire had a 6.5 on the same fault that goes by me that had the 5.8 in 82. So people aren't looking back to figure out how this all works. So basically what I'm saying, we're going to get 6 and 7.
In 1870, you remember the earthquakes we talked about in California?
Yeah.
Large earthquakes from 1870 up to 1906, San Francisco area. Charlevoix also went off in 1870 at a 6.5.
Yeah.
So
what they say is basically just was like an aftershock to the other one. That's basically what they say. Because it's same area, Charlevoix seismic zone. So pretty close to where the 1663 quake was. But going back into the 1600s, so that was 100 years before Cascadia, you had a 7 and a 6.5 on the East Coast. You had like another 7, New Madrid. Then you had Salton Sea, high 7, 8, all before Cascadia went off. So if it's following that same pattern, the East Coast and the middle is going to get pounded with big quakes before Cascadia goes off, based upon what it did the last time.
Well, again, some of the information that I've been following suggests that the monuments in D.C., the Washington Monument will lean pretty severe, and there will be damages to the monuments that will be very, very, very extensive, and that will be prior to the other New Madrid quake that's going to happen, and prior to the Southern Cal earthquake that will happen, which is everything is related prior to that to a hurricane that's supposed to hit Southern Cal and move across into New Mexico, into Dallas, into Texas. So there are people that have been given information, and they've relayed that information, and they're forecasting now, um, eh, based on their source, which I kind of trust that source because it hasn't done me wrong. But it's interesting that even the 1937 information that we've gotten from that young kid and relayed to us in late 60s and early 70s talks about how Colombia, Central America, Mexico, and Southern California are all connected. And what we're seeing just in the studies that we've done here and in the last, I don't know, 3 years, we can see the pattern persist. Why? Because these all are in this, although they're different systems, they're all interrelated. And when one happens, you gotta say, wait a minute. Okay, let me remember this. Okay. And then we can say, okay, this is a place of interest. Not a forecast. This is a place of interest we're watching. And when you see the big numbers like the 7s and the 8s and even the 9s, which translate as well, mainly the 7s and the 8s translate, you can see that reoccurrence through North America, Central America, and South America, and in the Caribbean, even up in Alaska. And you can see it over in the Kamchatka. You can see it coming down the backside over there through Japan, in the Philippines. And get this, all the way through Greece. Greece keeps coming up in the middle of these things, man. And it's like, now you start to see a system. Say, wait a minute. Why are we seeing these kinds of quakes? Bang, 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 bang in a 1 or 2 year period. Remember, most of us live on a microwave mentality. We think it's going to happen real short. But a geologic time is different. That's why we go, well, we're only going 1 or 2 years because our little brains can't take it, to put all those numbers in our head. But it's very interesting how we can see quakes happen and then rehappen and then rehappen over long periods of time or even short periods of time. And when you start seeing the big ones, then you start looking in the like common day, like I think we called one here just a little while ago. We weren't even trying. Well, okay, it's going to be maybe a 3 or 4 in Southern California. And guess what? It happened. Like, what? We just talked about that the other day because we were looking at something like a 5 or a 6.
Yeah, it's still following the same procedure. It's just not as powerful.
Yeah, it's not as powerful. So it's interesting that can do, and I'm sure the USGS has their AI system, and I think that their forecasting machine, they call it. They're watching this too. And I don't know.
And they're going even more in depth because that's where all the satellites is sending the information back to.
Right.
Is the place there and wherever it is.
Right. And in our disciplines, our crisscrossing of disciplines, more than just disciplines, we're also just information gatherers, all we are basically, and then regurgitating that, trying to present it in a way that's, entertaining as well as informative. Take everything we say with a grain of salt, and it's like eating fish. Throw out the bones. Don't eat the bones. Just eat the meat.
So now we got to do 1812.
Yeah, interesting. 1812. Let's get right into it. Yeah, he's keeping me honest, man. He's keeping me honest because I'll ramble. I'm a preacher at heart. Come on now.
Yeah. So I put the wiki in there for that, but we're just going to read the first part of it, and then because we've talked about it before. But
1812, San Juan Capistrano, also known as the Capistrano earthquake or the Wrightwood earthquake, occurred December 8th at 1500 UTC in Alta, California. At the time, there was a colonial territory of the Spanish Empire. Damage at several of their missions in the region. Pueblo de los Angeles include Mission San Gabriel, Archangel, and Mission San Juan Capistrano, where 40 prisoners were killed during the collapse of the church on the morning service. See, they were out there worshiping. All of a sudden, the damn ceiling came down on them. I've been in that church, pretty far out. Tree ring and paleoseismic evidence show that there is a strong likelihood that the earthquake originated along the Mojave segment of the San Andreas Fault near Wrightwood, but the faults have been suggested as the cause. But other faults suggested the cause. Several studies in the 1980s placed a shock along the southern Newport-Inglewood Fault near the zone of the highest reported intensity. This fault is near the coast and the most significant damage of the missions, but later work, trench sites along the San Andreas Fault, excluded it for this large to very large shock. Dynamic rupture demodeling made possible another proposal in the 2010s involving a dual rupture scenario with both San Andreas and San Jacinto fault zones. Each of the studies worked with limited data, and the effects of the shock and various fault ruptures details led to the Mercalli intensity of 7, very strong, to a 9, violent, being proposed magnitude 6.9 to the low 7.5s on the high end were also presented. Historically, just remembering, there's very, 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 very few quakes that exceeded 7.3 in Southern Cal.
Yeah.
So when you get in the other one that in Southern Cal that has exceeded that we know of for sure was the was it 1872, right? Right, 1852 or whatever it is.
1857.
The Owens Valley.
Yeah, Owens Valley was 1872.
Yeah, that one was somewhere up around 8, or maybe not.
High 7s.
High 7s, yeah. And depending on the rupture of the land, that's kind of do the damage, and they all tell you what that is. Now, today they don't talk about the same. When we talk about the magnitude, they're not talking about magnitude like we normally talk about magnitude. They have a different kind of system they work with. They look with, the kind of rocks, and they look at the fault, and then they look at how much damage was done and how much rip happened. And then they determine this is this size of fault. A magnitude from 6.9 to the low 7.5s on the high end of this fault. So this is 1812. What else happened in 1812, Canuck?
All the new Madrid quakes. But before we do that, before we get to that part, well, this one was the one that was on December 8th.
Mm-hmm.
But also 2 weeks later,
Mm-hmm.
in 1812, so this is at the end of the year, December, we had the Santa Barbara quake.
1812 Ventura quake, yes. Also known as Santa Barbara earthquake, occurred on December 21st at 11 Pacific Standard Time. The 7.2 earthquake was assigned a maximum modified Mercalli intensity of a 10, or extreme. The seismic shaking was followed by a tsunami that considerably damaged places present-day Santa Barbara and Ventura County, California, which was at the time the territory of the Spanish Empire. One person was killed during the earthquake and another from an aftershock. The earthquake occurred while the region was recovering from another event, December 8th. So 1812, Southern Cal pops twice.
Yeah, 2 7s.
So what else happened in 1812?
Well, we're going to go to the GIA list, and we're going to get excited because you'll see.
Woohoo! All right. You want to do it the year before?
Yeah, you can start with 1811.
Well, 1811 United States. Bam, bam, bam. All four of them.
Because
And
that was the New Madrid quakes.
the Moon Madrids. Yes, man. Yes, sir. And share this map instead.
So 3 sevens at least.
3 sevens here. And there's 1811. 1811. 1812. 1812. So big quakes happening right here in these 2 years. And then you have I don't know where's San Felipe at? Do you know? I don't know where that one is.
I gotta go to it here on my list. San Felipe, I think like El Salvador or something. San Felipe.
Japan popped in 1812. Pretty good one. Jamaica, 1812 as well.
Yeah, I didn't know the Jamaica one until I looked on this list.
Yeah, pretty interesting there. Very interesting. Now, again, the Caribbean as I call it, right?
Yeah.
And of course, then we got 1812 again, Southern Cal, 1812 Southern Cal, right? So interesting.
Barquisimeto, San Felipe, and Caracas were on the same day.
Yeah, Caracas, right here.
7.7.
Okay. Now Caracas is at 12-3, right? The day after, or the day, a couple of days before Southern Cal. 1812, that is. What year? What date is that one? Caracas 12. Oh, 326.
March 26th.
Yeah, it happened, and not too long later, Southern Cal hit. So
yeah, right after Jamaica.
We got sharp.
So Jamaica was a month before SoCal, the Jamaica quake, which I didn't know about that one. I knew about all the other months.
Mm-hmm.
Yeah, it was 18, 12, 11, 11. See, so November. So like a month before the 2 SoCal quakes. And I forget what the Jamaica one was. I think they said like 7 or something. I can't remember what it was.
6.75?
Yeah, 6.75. Yeah.
Right. Or close to a 7.
Yeah, and that's also the same year La Soufriere blew up at BI level 4.
And that's on an island as we're we're watching this. So La Soufriere is right out here. So we have 1812, La Soufriere, 1812, and 1812. Yeah.
And so we had the same thing again, Caribbean going nuts, and the middle of the U.S., and then West Coast U.S.
Right.
So it's like the same pattern again.
So, yeah. And then later it's up in this Canada one is 1870, so it's earlier.
So that's 1812.
I'm looking at 6 years earlier. We have a Colima quake down here, but it's 6 years. It doesn't mean that there weren't other quakes. It just means, hey. And here's a Meridia quake. How big is this one? There's a 6. All right. So we have a 6. We have a 7. We have a 6, 3/4, all in 1812. Southern California pops with 7s. And
well, to me, it makes sense when you think about how the plates are going, right?
Yeah. These pushing up that way. Yep.
So it moved big farther east, then it moved big in the middle, and then it moved big in the west.
Yeah.
So that's what it's doing again.
Yeah, that's what it's showing us, everybody.
So isn't
And
that
if we go backwards, no, we go up forwards to 1857,
yeah? And
which
you'll
is
see it's the same thing.
Fort
'Cause that-
Tejon.
Yeah, because it was the quake. I think was January 9th, 1857. So
All
you
right,
have
so
to look what it's doing before that.
let's cruise on down to 1857.
Yeah.
Dun, 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 dun. All right.
So you'll see it's the same once you get there.
Yeah, let me get there here. Wow, crazy. 1851. What's this? 1852. Are we? Shoot, howdy.
You're going back a bit farther than I did.
730.
Yeah.
That's a 7.3 up there in Reno. Okay, you said at 1857. What I did is I was scrolling down. I see a Chile in the United States. Go, what? Right, and that's only in 2 years, right? So we have Chile's popping off real big. Then Reno pops off at a 7.3 in 1852. All right.
Yeah, well, we haven't done.
Then we have Jamaica again, right? Or Jim said, no, that's not.
But-
yeah, it is.
Yeah,
Yes,
but
look
you're
at 1852.
that it's the same pattern when we
Another 7.5. Another 7.5 off of Cuba, right?
because I don't
82.
even know how many we've done now, but by the time we do it in every state, you're going to see how,
All right.
how it's working.
Then Cuba pops again, the same year. So 2 big quakes down here, right? And this other one was up here,
Because I'll worry
1852.
about Nevada when we get to Nevada. But
Yeah, we'll be talking about that one. Yeah, because Nevada's in play all the time, everybody, and not everybody knows that. Then we have a Mexico 1852, which is right where in the Delta. All right, and I know that I'm going the long way around, but yeah, significant quake
he's
in
getting
Mexico.
distracted before we get to 1857.
Yeah, and I'm 5 years early. All right, only because I saw Peru. What's going on in Peru? And that's 5 years before what we're going to talk about now. So, and Valenzuela, which is on the other side, 1853. So that's crazy, right? We got up here Cuba, down here, and then up in Reno, right? Banging. All these things, we keep seeing the same suspects happening. Large earthquakes happening in similar geographical areas. It's not like it's where would it see? It's not like happen along East Coast or happen in BC, which we do find some similarities in BC. We just need the records from BC.
Yeah. Well, we're focusing on SoCal right now, right?
Yeah, SoCal, right. So, and then you'll see it happen over again.
But it's going to change when we switch to different states. But you'll
Right.
see what pattern applies to
Right.
whichever state we're on.
1856, the Gulf of Honduras. All right. So all these ones here.
Yeah. So
Those
this is the year before
Right.
January 9, 1857.
Now remember, we were talking 1852, all this other stuff. Now we're talking 4 years later, it starts up again. Big quake in Honduras. And then 1857 up here in what was it called?
The Fort Tahoe quake.
7.9.
Yeah.
All right. So the one down here in the Gulf of Honduras, 7.0 to a 7.69. Big quake. There's the plate boundary line that comes right through here, moves right in through Mexico, comes up the coast, and bang.
So that in August, the Gulf of Honduras.
Now these are larger earthquakes that are on this database. I bet you if we, when we get to heaven and we ask the Lord, he'll say, oh yeah, this was happening here. Bang, 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 bang. And it led right up.
Yeah.
So,
and see what it was doing later on that year, later on in 1857. Yeah. See
El Salvador popped right there. Bang.
Yeah.
I don't know where that. And Jamaica, bang.
Yeah.
The next year.
It's like the same suspects going off.
Right.
And like the ones that are in this are big enough quakes that whoever was there noticed them and like wrote down so that they have records of it. So if nobody was there and didn't write anything, then it doesn't show up on that list. Right. The other ones are from them studying the faults, figuring out when it went off previous times. Because they know the last 4 times that New Madrid has gone off too. But we'll talk about that when we get to...
And then you go to 1860, you can see Haiti, Guatemala, Honduras.
Like
Honduras and Peru again.
This list a lot because it goes back to the year 1000.
Right.
So when we start like looking up the quakes that they figured out from studying trenching and doing the fault itself, you can use them because they get a date on it. It's in a certain year. They usually don't know what month it is. Sometimes they figure it out like if it was in the spring or whatever, but like what season it was, but not always. But you can still use those, what they find, and then go back and look at this list that they do have records of. You can find out what was happening like during that same year or around that same time. And that's basically all that I'm doing. I'm trying to reconstruct how the quake appeared. So I'm like a quake forensics person or something.
The quake whisperer. Wait, I can do that better.
Well, it's more like forensics because you're trying to figure out where it came from and why it did what it did or why it showed up there. When everybody that was there didn't know what was going on in all the other places, so they just say, oh, well, it's all random. Well,
tonight, on the rabbit hole, the quake whisperer.
Well, it's not whispered because it's like
it's a whisper.
I'm reconstructing how it appeared, so it's like forensics.
He's the quake.
Because I'm trying to figure out where it came from, how it got there.
He's CSI of earthquakes.
Yeah, that's basically what I'm trying to do.
That's too funny.
Yeah, so I'm like, make CSI. So you can have branches in Hawaii and Papua New Guinea and Australia. You can have lots of spin-offs because one is all related to the other, just like when they try to do the CSI shows.
That's pretty crazy with what you're again, this is the hypothesis that we're working with, everybody. We look at 1 to 2 years and we can see at that, okay, well, what happens if you branch that out a few more years? You start to see, well, if you want a lack of a better word, a triangle of events happening. And you'll see the areas moving as a result. And then a little bit later, you'll see it moving again, and you'll see it repeat. The same kind of suspects over and over and over again. And it, what it does, it makes the world kind of small. And so anyway,
we're going to do the same thing when we get to the San Francisco quakes.
Yeah.
And you'll see it's very similar.
In 1857, the quake ruptured about 350 kilometers or 220 miles of the southern part of the San Andreas Fault. The structure that accommodates most of the displacement along that transformed boundary between North American plate and the Pacific plate. The Pacific plate is moving north relative to the Sierra Nevada Great Valley block of the North American plate, about 38 millimeters or 1.5 inches a year. The displacement rate along the various sectors ruptures is 34 millimeters or 1.3 inches per year. Along Parkfield and Colombe, and then at Carrizozo, and the Big Bend sections of the 27 millimeters, 1.1, and 29 millimeters, 1.1, along the year in Mojave North and Mojave South sectors. So the parts north of Garlock run about 1.5 inches. Everything down south is about 1.1. What's that tell you? 0.4 gets stored every year. In what? In that bend. And it gets distributed out to the adjacent fault systems, as we've talked about over and over. All these other fault zones gets distributed because it's blocking right here. This is the Tejon, Garlock, area, and Fraser Park, right? And Tejon, whatever. The big earthquake happened up here that we just talked about in 1857 to Fort Tejon. So it's interesting to note that those two numbers that they use, the 1.1 and the 1.3, so 0.2 gets stored every year on average. Some years it's more, some years it's less. All the numbers are on average. So, it moves in every 10,000 years, it's moving at a certain distance, right? So take 1.5 inches per year and multiply it by 10,000.
Yeah. So between 1812 and 1857, so in 45 years, you had 3 sevens in SoCal. That's pretty crazy. In a short period of time.
Yeah, I think it's 104 feet per, if I did that one right, 104 feet per 10,000 years. And for 1 million years, there's 10 times that, right?
Yeah. And Julian Lazo, he's the guy that was the first one to say that 1812 was both San Andreas and San Jacinto. He also thinks there was a 7 up around Garlock Ridgecrest area in 1812.
Right. So the San Andreas is basically moving every 1 million years 1 mile, according to what their numbers are, right?
So according to what he thinks, that means there would have been 3 sevens in SoCal, same as 3 sevens in New Madrid, according to what he thinks, based upon his computer models and what he does.
Pretty far out stuff.
Yeah.
Well,
and if you look up where he thinks those were, it makes a triangle, and so do the 3 New Madrid quakes. So I thought that
it would be interesting to see, to go back in time and see what if we were on a solar maximum, can't say the two words together, a minimum or a maximum in those during all these events, and to see how much there is a play, or if at all.
Because it's on the Australian, the same site that we go to for the solar stuff. They have it where they show all the years, and then whether it's minimum or maximum, if I can find it. It's like a chart. And they show
we've had an X2 flare here just yesterday, or today, was it? Yeah, early this morning.
Solar min chart, it's called.
Right. The solar wind today was at 404. The density is at 3.5 protons per cubic meter. We have an X2 and an M2 flare here today. This is November 6th, 2024. And there's a sunspot 3883, which is kicking out, and 3886. Both of them have mixed polarity fields and harbor enough energies for an X flare like we had today. And we're also on watch for a G1 geomagnetic storm through the 7th. And when a CME is expected to hit Earth's magnetic field, it's not supposed to do a whole lot, but it's just supposed to graze us. Also, there are strong flares that are underway. Solar activity has reached high levels on November 6th as sunspots 3883 and 3886 crackle with strong solar flares. The most powerful of these flares was the next two that occurred from 3883. And I do have an image for you if you want to see it. There you go. Bam! Almost directly right out of sea. We're right here. Look how close that is. Wow. You know that's going to do something, right? So looking at the X flares here, share this tab instead. You'll see it right now. We're at a rising. We're in an M right now, an M2.06 at this moment in time. Here's the X that we had. That happened at roughly, the peak of it happened at 1340 yesterday, and we're already at 415 today. So I had a big strong flare, big strong M right afterward, another M and 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 another M. Crazy what happened after that X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 flares, M flares after that X. And then shortly thereafter, we had 2 more, and we're already in the second one. Prior to the X, there was 1, 2, 3, 4, 5, 6 M's. Okay. Now we've had more M's afterward, but that does not exclude or preclude that we won't have another X. Looking at the 7 days, the X that we had is the strongest of what we've seen thus far. So that's kind of interesting as I jump ship from our study onto what's happening in our planet today. Often we do these things. We do this in the morning over on twitch.tv/Joe Slick Live in the mornings, somewhere around 7 a.m. Depends if how tired I am or if I got to go to work, which I got to go to work every day. So I try to work it out. There's twin solar winds. Bang, bang. Look at this triangle and this triangle. Uh-oh, Waggy. Uh-oh, Waggy. Solar wind come out of the north, solar wind come out of the south. There's 2,349 potentially hazardous asteroid. That's an asteroid that is a football field size, 300 feet, right? Or larger. Traveling roughly 238,000 miles from Earth toward the sun. Not the sun toward Earth, but from Earth toward the sun. Or closer. And today is the 6th. And there was 1, 2, 3, 4, 5 rocks. All these rocks are 36 feet across, 30, 69, 18, 36 feet across. The closest was the 36 footer. It was roughly 200 or 300 and what is it? Now I got my hand. It's 238,000, 0.8 percentages of that. So maybe 200,000 miles away. And it was just a 36 footer traveling at 8.6 kilometers or about 5 miles an hour, 5 miles a second, 5 times 60. That's 3,000, or is it 300, right? 360 again. And then you'll see, yeah, about 18,000 feet per second, per minute, miles an hour. Sorry. Anyway, fast. And there's other ones that have gone faster, but nothing has real been dangerous to us. our satellites are 100 miles up, so or less, I think, thereabouts. The Class M chance is 80%. Class X is 35. We've already surpassed that. Geomagnetic storms, probability of 35% chance right now for the mid-latitudes, 10 for the uppers. Looking at the tremors today, there weren't any tremors yesterday. All right, none. All right, so what do you do with that? I don't know what you do with it. It's like, all right. So the sun's semi-active. I'm looking at buoys right now. We do have some weather. There is a tropical storm? Yeah.
Hurricane.
A hurricane moving in the Gulf of Mexico, moving towards Texas-Mexico border from Havana, Cuba.
Yeah,
So it's moving due west.
Oh.
Pretty crazy.
Which
And-
means
go
God
ahead.
heal. That's what the name means. Raphael.
Raphael, God heals.
Yeah.
Crazy, right? Wow. Raphael moves into the Gulf of Mexico or the Mexican basin. And, we had a pretty amazing election that took place here in the States. And that election is a guy that was supposed to be knocked out completely came back and won it all. And not only won it all, he won it bigly. Crazy. Also, we have a tropical depression off the coast of Mexico, somewhere Guerrero out there, and it's moving due south. So that's happening. Have some 5 states in North America that are dealing with snow. Looks like New Mexico right now, Colorado, Utah, Wyoming, and maybe even a little bit into Kansas and Nebraska. Crazy. Don't know how that's going to play in on that storm. Looks like that storm is kind of moving. Yeah, it's going to go more north. It might move into the Panhandle. What do you think? Did it say it's going to go just going to hang out in the Gulf or what?
Well, yesterday they thought it was going to go towards Louisiana, but
Yeah,
now they have it going more west into the Gulf, so they don't know where it's going to go. Basically, right now.
Yeah, they got it going right into. Well, it's going to clip Cuba, so it's got to go over Cuba, and then come out the backside, and then go due west. So that's pretty crazy, to tell you the truth.
Yeah, and I put the link in there because I found it to the one that has the solar max min by year and the average, whatever mean.
Right. Yeah, I have this one, but I'm going to put it where I can research. No, I'm
So
going to
you
put it on freaking.
You can look it up by year just to see.
You can from 1700 all the way to 2014.
Yeah.
So they have it pretty good. So interesting that 1700, the max was the next year, just like it is right now. The max is in 2025. Oh, we were talking about us. We were talking about 1750, or were we talking about 1850 today?
We were talking about 1857, 1812,
Okay, all right.
1690.
Yeah, and 1860, that was solar max.
Yeah.
So we were moving into solar max in 1860 from 1857.
Yeah.
And then we talked about what other number? Oh, the 12. 1812. Get this, 1816 was max, but 1811, 1812 was not. That's 5 years before, so it was at solar minimum 1812, 1811.
Yeah.
So interesting there. 1857, solar minimum. So those several different quakes, how the sun or the solar, it doesn't mean we didn't have a flare on those days. It doesn't mean we didn't have an X or some sort of other event.
Or we were getting a geomagnetic storm from a
Correct.
cosmic rays.
Yeah.
You can get cosmic
There
rays.
are several ways for these things to work out for what happens, and solar is one kind of thing we look at. We'll also look at weather. That's why I mentioned the hurricane.
You can find that information. It just gets harder the farther you go back.
Right.
Because I've done it for a bunch of ones in the 1800s before.
Right. So
Some in the
the hurricanes down here in the south, it's moving due east now toward the border of Mexico and Texas here. It looked to me like it was going to go up the Panhandle or Louisiana, but now the Hurricane Center is saying
there's all sorts of crazy solar stuff that was going on before 1886 Charleston.
Right. Yeah. Well, again, we're looking at more than just Coulomb stress, which is built up stress on a given fault or given rock type or sediment type or volcanic type, plate boundary or non-plate boundary, transform fault, strike slip, or spreading center.
And the great comet of 1811 was flying over when the New Madrid quake started.
Yeah.
And people could see it.
Yeah.
So it's like a visible one.
Right. And that's the one that went into the sun, right? It broke up, parts of it went into the sun, and the other parts just keep coming around year by year now.
Yeah.
Yeah.
I don't know when it did. You'd have to look up what the great comet, they called it back then, the Great Comet of 1811.
Right.
But then it says what they call it now and what happened to it. I don't remember the name.
I'll tell you.
So that was happening at the same time as the New Madrid quakes.
1811 comet, C1811 F1, a comet that was visibly to the naked eye around for 260 days, the longest recorded period visible until the appearance of the comet Halley-Bopp in 1997. I remember that. I saw it. In 1811, it's at brightest when it was 1.2 AUs from Earth. That's pretty far, actually. It displayed an apparent magnitude of 0, with it's easily visible with. Okay. Comet discovered March 25th, 1811.
They have a database at Harvard of all the visible comets that were seen over North America, which I've used that to match them up with quakes and wildfires and all sorts of different things.
Mm-hmm.
It's pretty wild.
Which Southern Cal right now has a bunch of wildfires, but they also have Santa Ana winds, and places are burning right now, big time. Interesting there. Today we've had a couple of earthquakes that pretty significant quakes, I should say, around the planet. The Volcano Islands just south of Japan had a 5. And the Celeb Sea had a 4.3. And if I looked on USGS, I'm just going to go through a few of them here. Fiji popped in with a 5.1 and a 5.9. Oof. It was deep too, 431. Near 6, right? And then 5.9 over in Papua New Guinea. and then Indonesia side 4.6, and then Los Palos, Timor 4.5. That's east. That's near the Triple Junction there. It's also east of Little Toby volcano, which is it popped 40,000 feet the other day, and that's pretty crazy. Taiwan had a 5 today, and then the volcano islands off the coast had a couple of 5s as well. China came in just north of Bangladesh at a 4.7, and Puerto Rico has a few little quakes, and 3 2s and 2 6s and 3 5s. Chile with Bolivia border had a 5. Then off the coast of San Diego had a 3.0, San Clemente Island. Yeah. Pretty far out. And then also up there, Petrolia had a 2.6. And stovepipe wells, again, still banging out there in Death Valley. Death Valley is told to, at one time, have a lot of water. And I don't know how it would get there, but it's told that it will get a lot of water again, be like an inland sea. Yep, as the Grand Canyon folds up, collapse, and maybe the dam doesn't work anymore, or the 3 dams or 4, whatever there, how many are on the Colorado? I don't know. Let's see, is there anything else, Canuck, that rang your bell today?
No, I can't think of anything else.
Yeah.
Yeah, Israel's blowing up everything in Beirut again, including more stuff at the airport. But
well, you don't play with the bull. They've taken it for as long as they're going to take it, man. Now,
because they shot rockets.
I want the war to stop. I want the war to stop, and I want those people to
twice today. So then Israel said, "Well, we're going to take out the airport." So that's what they did.
Right. Just crazy.
They blew up a warehouse that was like in between the 2 runways, and all the shrapnel went all over the runways. So now they can't use the runways, and pieces of it went into the main building. They said to what's the word I'm looking for? Where all the passengers go to. The main
terminal.
building.
The terminal.
Yep. Oh, yeah.
They hit the terminal?
No, they hit a big gigantic warehouse building that was in between the 2 runways. But when it blew up, because it kept blowing up and burning for hours.
Oh, they had bombs in there. Secondary explosions.
Yeah, so it shot stuff all over the runways because it was in between the runways. And the shrapnel went out and went into the terminal building too. So now Beirut airport's all shut down. Yeah. And this was after they fired rockets and drones at Ben Gurion Airport in Tel Aviv twice today.
Yeah, so them sons of bitches keep doing it. Look, they got to learn that someday you just got to say, I don't want to do this no more.
Yeah, and, so now,
and
the airport in Beirut now anymore. Because it was only one airline flying in there anyway, whatever the name it is, I can't remember. Middle East Airlines, MEA, I think is the name of it. So it's like based out of Lebanon, but it flies to like all the Middle Eastern countries. So, but now they can't fly there anymore. So there's no way they're going to be able to smuggle any people or any more weapons and unload them by the airport. So that's what happened there earlier tonight, because I saw it right before. Well, it happened earlier today, but then I saw videos of it just before I came on to do the rabbit hole. So I said, oh yeah, well, I guess they said they were. So it didn't take them too long after they said that, because I heard that earlier today, that they were going to since they attacked the airport twice, they were going to make it so that nobody could use the Beirut airport. So that's what they did.
Well, interesting. I see today, interesting. This young gal lived in 1848 and to 1866 when she disappeared. Somebody was updating a house in Illinois,
Yeah.
and found a person buried in the wall who died more than 150 years ago. Crazy. And now
So
they identified who that was.
would have been before the Fort Tejon quake then.
Yeah. Pretty crazy, man. Well, do you have anything you want to add to anything, or?
Nope.
I think it was pretty good.
Because next time we'll go off the coast and start working our way up towards San Fran.
Yeah.
Which will be seeing Simeon Quake and Coalinga and all those ones. Working our way up.
Yeah.
And then San Fran's probably going to be at least 2 episodes because there's so many.
Yeah. We're gonna enjoy that one.
Yeah. And then we'll have to do Lassen and Shasta out around that area, and then probably Tahoe and
which is very interesting to do up in that area. Yeah. Very interesting.
Because it was active around the same time as Lassen erupted, all up around Shasta and all those areas. But it seemed to be, from all the stuff I could find, it all seemed to be in conjunction with Lassen going off. So when there was like obvious quakes up in that area that everybody felt, like I imagine you get little ones there, but they're not super noticeable. From any of the stuff I've studied about it so far. But when you get into Tahoe and Lake Almanor up there, it gets quake swarms. And a couple of other, what's the other ones I looked up? I can't remember now. But they're all like on that same western side of Walker Lane, technically.
Right.
Yeah. Well, basically everything from Mammoth on up. So Mammoth, Long Valley. Then Tahoe, then Susanville, Lake Almanor, all that stuff. Because Susanville's had fairly noticeable quakes before, which is basically on the edge of Walker Lane. Because Susanville's like kind of right on the border, California and Nevada, pretty close. So when I started studying all that, I said, "Oh, look, that's interesting." So I've been kind of all over the place, California and Nevada, and all this stuff I've been doing over the years. I think I've pretty much been in every state looking up something. Pretty much.
Right.
And when I go in and start studying the quakes in each one, then I see, oh, look, that's the same year as this one. Look. And then I connect all the dots. So it just keeps snowballing the more I do it.
Well, it keeps it keeps our interest what's going on there.
Yeah.
You know.
And like what's interesting about New Mexico, its biggest quakes that were the most noticeable and biggest ones they had was the same year as the San Francisco quake. So I thought that was interesting. So New Mexico responded to San Fran, the big quake in 1906.
Mid-Indian Ridge, class, moderate, magnitude, 5.4, depth, 10 kilometers, 10 minutes ago.
Mid-Indian Ridge, it said.
Mm-hmm.
So we're getting lots of
the Atlantic is missing. The Mid-Indian Ridge is happening. Is it moving from the Atlantic, or is it moving from the quakes over in the Java Trench? Which way is it pushing? Or is it coming from the north? Don't know.
Or it's all coming from the South Atlantic anomaly.
Someday we'll talk about that in detail.
Yeah, because
Well,
we just had all the flares in the X-Flare.
Yeah. Well, I appreciate you, Canuck, being on here with me and going through this studies that we do. I know those we get a lot of traction on other channels rather than on Twitch. We do have our base people on Twitch, but meaning our foundation and our group. Twitch.tv/Joe Slick Live. We're 24/7 over here watching earthquakes. And there are a group of people that are hanging out, can answer your questions, or, you can be there in the morning when we do the morning report, or the rabbit hole on Wednesdays at 7, Saturdays at 7. Now, if we're going to do something really big, like have a long time, like we're already 2 hours and 31 minutes into this one. We thought it was going to go 1 hour, but yeah,
We're doing more stuff than what in there.
Yeah. Sam, we have a good time too doing it. So,
But that's what usually happens with us.
Yeah. I don't know. It's fun. And how is looking at rocks fun? Well, it's not looking at rocks. It's looking what makes up the rocks and how the rocks got where they got, and
all that quakes, breaking all the rocks.
Yeah.
That's what we're doing.
And lifting up the rocks, pushing down the rocks, subsidence and uplift. Yeah, all that, pressure. Under pressure. I appreciate you, bud. And I'm going to mosey on off to bed and start this again tomorrow morning. And look forward to Saturday if you're available. I know you've been...
We're downgrading it.
Location, Mid-Indian Ridge, class, moderate, depth, 10 kilometers, 13 minutes ago.
3.2?
No, 5.2, they said. So
5.2, all right.
5.4 or 5.3, whatever.
And didn't they just have one that upgraded from 2 to 5.4? I mean, 5.2 up to 5.4. Now they're downgrading another one, 5.4 to down to 5.2. One was an upgrade, one was a downgrade. Weird. And the same numbers. And same two numbers, by the way.
Yeah.
I wonder what somebody's doing out there. I did come across somebody who's, let's just say, ex-military. And they suggested that they know how to play with the sun and to get the stuff out of it they need. I'll leave you at that.
Well, that's what they did in Stargate Universe, because that's how they charged the spaceship.
Haiti may not have been in an accident. Yeah, remember that? Yeah.
But if we can do that, we should have starships that they power by the sun. They're like, that's what they say.
Dilithium crystals.
Well, we already need lithium for the batteries, so you have to have dilithium to run the starships.
Remember, don't get none on you, okay, everybody? Love you.